Hello students, in this video I want to change your perspective on how you might think of linear systems of equations. You're thinking about them correctly if you're looking for a point of intersection between two lines or two planes or two hyperplanes and so on and so forth. That's perfectly fine. However, it would be fruitful if you were to think of linear systems as what we call linear combinations of vectors. And so here's the perspective I'd like to offer you. Look at the columns here, and we know how to convert this to a matrix equation. We look at the columns and we think, oh, this is x1 multiplied by the first column, x2 multiplied by the second column. Done that in a different video. So this is what a linear system of equations would look like. And you might say, well, I know how to solve this system. It's if x1 is 6 and x2 is minus 7, don't worry about how we got those numbers. Let's just say for some reason you knew how to get those numbers or someone gave you those numbers. You could check your answer. 6 times 2 is 12 plus minus 7 times 1 is minus 7. 12 minus 7 is 5. 6 times 3 is 18 plus minus 7 times 2 is minus 14. 18 minus 14 is 4. So these two numbers work. What you have here on the left is what we call a linear combination. More specifically, this is a linear combination of the columns of A, of our matrix. So we think of this 2, 3, 1, 2 as a matrix A. Now that has some geometric significance, because when you see a linear system of equations, what you're really asking is, can this vector 5, 4 be written as a linear combination of the columns of A, or can this vector be written as a linear combination of these two vectors? Now, let me offer you some geometric interpretation of that so that I can make some sense of this for you. So imagine that the vector 2, 3 and the vector 1, 2, they're the two red vectors here. And here we have the vector 5, 4. Now remember from the parallelogram law, if I were to add these two vectors, 2, 3, and 1, 2, right, I would just get this diagonal of this parallelogram. But that's not going to get me to this vector here. That's not going to make this vector the diagonals of the parallelogram with these two vectors. We have to alter these two vectors some way, somehow, to get them to get this vector 5, 4 to be the diagonal of this parallelogram. And that's what being a linear combination means. You want to get this vector here, 5, 4, to be the diagonal of a parallelogram that is somehow the legs of the parallelogram are these two vectors. So let me show you a better picture. So here's our two vectors that are the columns of the matrix, and here's our vector 5, 4. You can see it's the vector 5, 4. Here's the vector 1, 2, and here's the vector 2, 3. Now, I want to make this blue vector a diagonal of a parallelogram that is somehow a modification of these two vectors. So I'm going to modify these two vectors by multiplying one by 6 and the other by minus 7, and when I do so, I get something that looks like this. So here's the vector 2, 3, it's multiplied by 6, so that gives us a 12, 18. And here's the vector 1, 2, and it's multiplied by minus 7, so that gives us minus 7, minus 14 down here. You might be saying, wait a minute, I don't see the parallelogram law in there. Well, let me make that a little more explicit. So let me put the legs of that parallelogram there. So here, once again, we're trying to modify these two vectors, 1, 2, and 2, 3, so that we can make this vector the diagonal of a parallelogram that is an alteration of these two vectors. So what is that? What are those scalars? we got this picture, and then if we put the legs of the parallelogram on here, there you go. So this was the vector 2, 3 that was multiplied by 6. This is the vector 1, 2 that was multiplied by -7. If I connect the legs of the parallelogram, you see that we do in fact get the parallelogram law, and 5, 4 is the diagonal of the combination of these two vectors. And that is a perspective that you will find very fruitful and very helpful when you get into some more abstract ideas in linear algebra and you start studying things like column spaces and row spaces and linear independence. All right, I hope you find that helpful. Good luck.